Okay, so in a previous video we talked about synthesis, and we said let's do example 1. Let's think about all the reactions that we have in these terms here. We've got ways of changing functionality, ways of introducing functionality, and ways of eliminating functionality. And then we've got other reactions which can't really be categorized in those fashions. They really have to be thought about in terms of carbon-carbon bonds. We've got ways of making carbon-carbon bonds and ways of breaking carbon-carbon bonds. So let's do an example here, and let's do one that ought to be somewhat rudimentary. Let's do an example of, say, let's go from 2-bromopropane to that. Okay? Which is called, I guess, acetaldehyde. Not something I would expect. You don't need to know that, right? That's chapter 17 or 18. So for organic 1, that's organic 2. But you know how to make that, right? So first of all, we see that there's a couple things that we've got here. Number 1, we've got different functional groups in there, so we might need to change, introduce, or eliminate functional groups. And number 2, we've got 1, 2, 3 carbons, and over here we only have 2. So we've got to have a reaction that breaks carbon-carbon bonds. You see that? Alright, so the first thing we're going to do is think, what reactions do I have that break carbon-carbon bonds? I can only think of one right now. That is, at least at your level of learning in this course, I think you only have one reaction, and that is if you have that, right? This is ozonolysis, O3, and 2, I think in the last video I used zinc and acetic acid. For a little bit of variation this time, let's say it's dimethyl sulfide. Okay, that's a reaction. I don't know what page it's on, but it'd be a decent thing for you to look up. So that's one way we can make or break, that's one we can break carbon-carbon bonds. So I've got 2 carbons here, and each of these has just 1. By the way, you should be careful. This could also be 2 moles of CH2O. This is the same thing, right? And it would be scary if you saw it in a different fashion, right? Ethene, to 2 moles of formaldehyde. You'd be like, what? What's going on there? But as I see it like this, right, and I draw it like that to make it easier for my eyes. All right. So it turns out we're going to be breaking off 1 carbon there. Let's suppose we are going to be using this. If we're going to be using this reaction, and by the way, right, not only do we break carbon-carbon bonds, but we also introduce a carbonyl oxygen, which we have here. So this is a pretty good idea that this is going to be needed. And if we get a double bond here, can we think of any avenue from an alkyl halide to a double bond? And the answer is yes, we can. We've got ways of eliminating. Right? This is an elimination reaction. So I think you might be able to see where we're going with this. This is now just a 2-step synthesis. Now that we've identified these reactions, we go, oh yeah, definitely. I can take this. I can eliminate it, right, and then cut it. Okay? Which that structure, right? That's that structure, and there's the end structure right there. Now we have some waste. Does that bother you? Be careful. The question, the requirement for you to synthesize this stuff doesn't imply that you have to use everything. You're going to have some waste in there, and that's going to do it. So this is an elimination reaction, which we do with hydroxide, possibly tert butoxide, another example that we've used. Okay, strong bulky base. We'll look that up in the text. And then from here to here is ozone. It's that reaction there. Ozone and zinc and acetic acid, which is not what I drew above, but it's another way to do it, right? Two different ways to do the same thing. Okay, so there it is. There's your synthesis, and with a little bit of waste.